Hi Year 7, today we are looking at equivalent fractions. So we're going to start off with our starter grid again, pause the video, give yourself enough time to answer all 6 questions, and then when you're finished, unpause the video ready to mark these. Okay, you should have had enough time to do these now. So with your red pens ready, can we please mark the questions from the starter? They are up on there. Remember, if you have any questions, just post it on either Firefly or give me an email and we can go through together on these questions. Okay, so we're going to go on to the main part of the lesson. Remember, once again, you can pause the video at any point if you're still catching up with marking or writing something down. So equivalent fractions, we're going to talk a little bit about what those are today. So to start off with, as a recap from last lesson, I want you to write down the fractions that these diagrams are representing. So have a go now at thinking about how we can write down a fraction from a diagram and write them down underneath these shapes. You don't have to draw them, just write down the fractions. Right, so the way we talk about fractions from shapes is that we look at the amount of equal parts the shape is divided up into. So for example, this shape is divided into 1, 2, 3 equal parts. So my denominator for this fraction is going to be the number 3. Then we look at which parts of the shape are we looking at, i.e. which are shaded in. We've only got one part shaded in here, so the fraction for this one is 1 over 3. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9 shapes, so my denominator is going to be 9, and 3 of those are shaded in, so I have 3 over 9 for my next one. And finally, this one's going to take a lot of counting, so it might take you a little while, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 18, 21, 24, 27, 30, 33, 36 for our denominator on the bottom, and the ones that are coloured in are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my numerator is going to be 12. So those are my 3 fractions represented by these diagrams. Now what I want you to think about is, even though our fractions are different between these, it's the same amount of the shape shaded in. So all of these squares are the same size. It's the same amount shaded in. Well, actually, yes, it is, because even though we split it up into more squares in this one, it's still this part here that's shaded and this part here. There's even more squares in this one, but it's still just this part here that's shaded. So even though all of these fractions are different, they're actually representing the same amount of the shape shaded in. So these are what we call equivalent fractions, because they might be different in numbers, but they mean the same thing. Okay, so on the piece of paper you're working on, what I want you to write down is that equivalent fractions are the same amount of shaded in. So you write down equivalent, which is this word here, and that's equal to same amount shaded. Now, the way we can tell that fractions are equivalent is because we can times the top number, the numerator, and the bottom number, the denominator, by the same number to get another fraction. So we can see here that we have a half shaded in. This one's 2 over 4 because we've got 4 parts, but 2 of them are shaded in. 3 over 6 for the same reason, and 4 over 8, but they each represent the same amount shaded in. So 1 over 2 is equivalent to 2 over 4, which is equivalent to 3 over 6, which is equivalent to 4 over 8. And we can see here that the common part between these is, to get from 1 over 2 to 2 over 4, we have to times both the top number and the bottom number by 2. So what you're also going to write down is times the numerator, which is the top number, and the denominator, which is the bottom number, by the same number. So that's how we find equivalent fractions from these diagrams. Pause the video if you need more time to copy these down. I'm going to move on to the next part of the lesson. Okay, so here we want to write down 5 fractions equivalent to 3/5. So what that means is we're going to times the top and the bottom by 5 different numbers to find 5 fractions that represent the same thing but have different numbers. So to start off with, make your life easier, pick the nicer numbers to multiply them by. Even if you can multiply them by anything, I'm going to times the top and the bottom by 2. So 3/5 times 2. Well, 3 times 2 is 6, and 5 times 2 is 10. So 6/10 is an equivalent fraction. And then I'm going to do the same thing with another easier number. I'm going to go for 3. So 3 times 3 is 9, and 5 times 3 is 15. And keep going using equally simple numbers until we've got 5 equivalent fractions. In fact, I'm going to choose 10 for this last one because that's a nice easy number as well. So 3 times 4 is 12, 5 times 4 is 20, 3 times 5 is 15, 5 times 5 is 25, and finally 3 times 10 is 30, 5 times 10 is 50. So all of these fractions here represent the same amount as 3/5. So these are all equivalent fractions to 3/5. What I want you to do is pause the video and have a go at trying to find some fractions equivalent to 1/5. Now there are lots of answers to these, but as long as you're timesing the top and the bottom by the same number, you will get an equivalent fraction. Okay, so the answers that I've got are 2/10, 3/15, 4/20, 5/25, and 6/30, and all I've done is times by 2, 3, 4, 5, and 6. If you times it by 10, you would have got 10/50, but you can choose any number to multiply by as long as it's both the top and the bottom that you're multiplying. Okay, so I want you to have a practice at